So going through this real quick, I want to remind you before I start that we have today, tomorrow, Friday, and Monday, okay? After Monday, we are completely done in here. I'm not doing a project. I'm not doing like a Unit 4. There's a whole other unit to this course that is not on the AP test. It's not something we teach in this county unless we want to. There's no way we're going to do that. Don't worry. So when you come to this class after May 13th, you were sitting here, okay? We're just sitting here. You can work on other stuff or whatever. So usually what happens in that situation is students are like, can I go here? Can I go here? Can I go here? The answer is no, unless you have something from that teacher, okay? So if you want to go sit in Mr. Peruli's room because you're in band and you know, he doesn't mind, that is absolutely fine with me. He needs to contact me, though, whether in an email or write a pass for you. Yes, so-and-so can come to my class anytime on these days or whatever, okay? I can't write a whole bunch of passes and email and stuff, so you have to arrange that ahead of time. But the answer is yes if the other teacher says it's fine, okay? So keep that in mind. All right, like I said, you're going to read this first part. Let me just go through the FRQs. So hard test, no doubt, right? And FRQs are word problems in math, high-level word problems, you know, a lot of parts to them. They're a little scary, a little intimidating. Each of them is worth 6 points. No one is expecting, I mean, it'd be great if you did, but no one's expecting you to get 6 out of 6 on every FRQ. You want to find those points that you can make, that you can get without, you know, giving up, okay? And one thing we need to talk about is time. You only have 15 minutes per FRQ. That's it, 15 minutes. When we've been working on the mock in class, I kind of like let you just work on them because we're still in learning mode and all that stuff. Guys, pay attention. But remember, you only get, I mean, all 4 FRQs, you have an hour total. That's 1 hour to do all 4 of those. That is not a lot of time, okay? So let's go through some of the FRQs and some things to think about. FRQ 1, this is a place where I feel like you guys can make some points, 4 to 6 points here. This is going to be the one I think you can really kind of shine. Show some work, even if it's just writing something like h of 3 equals g of f of 2 equals 1. Meaning, like, even though this is a calculator problem, in FRQ 1 part A, I showed a little bit of work, okay? You didn't just write undefined. That won't get you the point. It doesn't mean you have to show how you got from this numerator to this, like, you know, showing every step, because it is a calculator. But you're showing what you did, basically, in your calculator to get to your answer. Notice the proper math language and notation. Things like that you want to be aware of, okay? FRQ 2, writing the equations that can be used as just plugging in values from 2 or 3 ordered pairs given in the problem. And we've talked about that. I think we talked about it yesterday. That in FRQ 2, you have, like, in this case, a table of values. It could be a graph that you pull ordered pairs off of. But the first question is going to be plug them into the equation that's given. And it was given. In question 2, in the prompt, it told you it was a quadratic. So literally just taking each of your y values and each of your x values and plugging it into ax squared plus bx plus c equals y, or f of x. So that's what those are, just plugging in the numbers. And we also talked about the fact that I did all this work and did it by hand. You didn't need to, okay? We got that confirmed. I got that confirmed after I had done all this. You can use your graphing calculator to find A, B, and C. So I want to remind you of that real quick. You would go into Stat and hit Enter for edit. And remember, list 1 and list 2, X's, Y's. Okay, so I plugged those in. Then I would go back to Stat where we started, over to Calc, and then you would find the regression formula for whatever we're talking about. Again, this one said quadratic in the prompt. I'm not guessing. It says it in there, okay? So quadratic is number 5, and we go enter, enter, enter. We need to remember how to store alpha trace enter, enter, enter. And then you can get your A, B, and C just like that, okay? And I'm going to come back to the calculator in a second. Also, average rate of change. Guys, you know, sorry, that's really annoying. The average rate of change is just what? What is that? What's another word for average rate of change? Slope. It's just the slope formula, okay? So don't forget, in slope, y is on top, x is on the bottom. That's what's important. Y is on top, x is on bottom. And show some work. Even though you're doing the subtraction or whatever, simplifying a fraction in your calculator, just show the steps, okay? Write out some work, yeah. L of 8, remember what this notation means. This is when I plug in 8 for x, I get y. So L of 8 is 14. So L of 8 equals 14. L of 5 is 21. So it's basically 14 minus 21, which is how I got negative 7.
No, I'm talking about the second one you got.
Here?
Yeah.
This one was, oh, I see what you're saying. I thought you were asking about that 7. Sorry. So here, you have a slope, negative 7/3. We're going to find a value that we're missing. So we don't know what L of 7 is. So you're going to use any point. I used L of 5 and plugged into the formula. So the slope equals L of 7 minus L of 5, which is 7 minus 5, which is 2. We don't know L of 7. That's what we're trying to find. I named it x. And then I just solved the equation from there. So multiplied both sides by 2. Right? So I got to this step, x minus 21 over 2 equals negative 7/3. So to solve that, Brandon, I would multiply this side by 2, multiply this side by 2. Put that in my calculator, I get negative 14/3, and then add 21 to it. And this is a calculator problem, so you could do all this in your calculator. Putting this in my parentheses, plus 21. And something to note, I know we've been taught in so many classes that we don't, like, it's a noun, right? Cars, people, trees, squirrels, whatever we're talking about, we round to a whole number. And then there's that whole debate, do you round down, do you round up, all that stuff. But for this test, we are being told to round to 3 places, even when it doesn't make a whole lot of sense, okay? We don't have 16.33 cars, but we are going to say that, okay? If any of that was unclear and you want another question, you have another question for me, please feel free. What do you need, sweetie? Oh, I have it up here. It's on Canva, but I'd rather you pay attention with me, and then I'm going to answer questions for you guys. So if there's something, like if I just went through that and you're like, wait, I didn't understand the first part, remember and ask me later. I will happily go over it with you, okay? FRQ3 we broke down yesterday and talked about. I made a video of it, so if you weren't here yesterday, FRQ3 video would be really worth watching because the feedback I got from all my students, or the ones that replied to me, were that it definitely helped. Or watch it again if you want to. But there's a really good way of getting a few points on FRQ3, maybe even up to 4 of the 6 points, even if you don't understand what the question is asking. Okay, so go back and watch that video if you want to. FRQ4 is probably the hardest one, as you guys saw when you did it. It's a lot of trig. It's having to know a lot of trig identities. It's like that one section, I think it was 3.12, the least favorite section of the year. We had that open note quiz. A lot of you dropped it. There's always going to be a question like that on it. And you're going to be tired. It's okay if this one is hard. Try to find some points you can get. Remember, you're limited in your time, so you don't want to spend too much time on one part. But don't beat yourself up with FRQ4 if you're having trouble with it, okay? And that's another one I can go over at any point before the test, too, if you want me to. Okay, this is a really important part, this part I'm going to go over. Test day tips with the multiple choice and the FRQ. What I've noticed is that when, especially that first multiple choice section, 1 through 28, no calculator, we're really boogieing through it, getting done with it with a lot of time left over. You know, on the test day, guys, you're going to be stuck sitting there for the whole time anyway. You're not going to be able to reach for your phone or anything like that. So just use the time is what I'm saying. All right. Flags, questions you're stuck on, because remember, you can write in the test booklet. Unlike the one I gave you in class, you couldn't write on just because I couldn't make that many copies again. But you will be able to write on, cross things out, cross out choices, all of that, okay? So flag questions. Remember, there's going to be questions that you don't know how to answer. It's okay, breathe and keep going. Do not leave blanks. A question you do not answer is definitely wrong. So you don't get penalized for wrong answers. You just get credit for right. So if you leave something blank, it's definitely wrong, right? It's blank, it's wrong. So at least try to get it down to two possibilities and then guess between those. We call it having a letter of the day. Pick on Monday, think what letter comes to your mind first, A, B, C, or D, and have that be your letter of the day or whatever you want to do. Watch your bubbling, check every few problems, be sure you're in the correct section. And here's a really good tip. So you're going to get a 10-minute warning. If you get the 10-minute warning and you're like, uh-oh, I have only 10 questions left. Or I still have 10 questions left, I'm making this up, whatever it is. Christmas tree it, or do your letter of the day. Go ahead and do that. And then start going back through your flagged ones and those 10 and try to put that last little bit of time into the ones that is worth it. Because if you have 10 left to go, for example, and there's 10 minutes left and you spend 5 minutes on that last one and all those get left blank, then you're definitely getting them wrong. So at the 10-minute warning, bubble everything that's left, then go back and start working. Okay, that way you don't have any blanks. On the FRQ, this is important. You very rarely hear math teachers say it's okay to write in pen. I mean, in my class, I'm really lenient about it because I hate pencil, hate it. And we are going to recommend that on the FRQ, you use pen. You can use black ink or blue ink pen on the FRQ. The reason is, and if you're against that, make sure you're using a number 2 pencil, not mechanical, that you can write, like you're going to put some pressure into it. Here's why. The College Board is going to take all of the answer sheets from all of you guys in the country and scan them. When we grade these this summer, it's not going to be like I have your physical paper in front of me. They're going to be scanned into a computer program, and I'm grading you here. So pencil could be a problem showing up on the scanner, okay? So something to think about. Don't erase. Unless you're feeling really confident about time, we don't want you to erase. It takes time, right? You're going to put a line through something, and we as graders know if we see a line through something, we're to ignore it, okay? We're telling kids not to erase. Another reason why is, besides it taking up precious seconds, is that when you scan with eraser marks, sometimes they show up, okay? The scanner kind of picks up on stuff like that. So you don't want to risk that. That's an important one. Show your work clearly, explain your thinking. If an explanation is hard, especially on FRQ2, draw a picture of what you mean, then explain the picture. We've talked about this, don't box your answers. I am horrible about that. I'm so used to putting circles or boxes around answers. We don't want you to do that, and we don't want you to write outside of the margin, okay? So keep all of that in mind. Circling or boxing an answer means we only look at that, and if maybe there was some supporting work that made sense, we don't look at it. If you box it, it tells us only look at this, okay? All right, you guys know we're going to provide your calculators for you unless you have one of your own. Make sure you charge it. Make sure you're in Radian mode, which if you clear your RAM, you are automatically in Radian mode. Remember, second plus 712, we have to know how to do that. No one can help you with your calculator. Nobody is that. Even if they knew how to do it, they wouldn't be allowed to help you, okay? You can't say, how do I clear my calculator? They're not going to do it for you. So you need to know how to do it, and that's here. One other thing, I said I was going to go back to the calculator. In STAT, I talked about one other time, but it's worth it for me to talk about it again. Guys in the back, Levi, Dylan, you need to be paying attention. There are times when I've gone to STAT, enter, and this has happened to students, and we don't know why it happens, but there will be times when there's only list 1 and everything else is gone, or list 1 is replaced with list 2, and there is no list 1. I have no idea why it happens, and clearing your RAM does not fix it. So if that happens to you, here's what you do. It's very simple. In the STAT menu, where we are anyway, number 5 is the setup editor. If you hit 5 and then enter, it'll restore your lists. It fixes it, okay? So again, STAT, setup editor, just hit that or scroll to it and then enter. It will make the list there, okay? So I wanted to bring that up again. Breathe, don't be stressed, blah, blah, blah. Last thing I want to talk about is unit circle if you wanted to practice. There is one for you. But as I've always said, you want to know quadrant 1. Quadrant 1 is where it's at, and then hopefully you could recreate the other quadrants with no problem. So, you all know this is square root of 3 over 2, and this is 1/2, and that's 1/2. Square root of 3 over 2, square root of 2 over 2, square root of 2 over 2, and those quadrantals. How many times have we talked about those? And then if you know all students take calculus, you know the whole thing. Remember, positive angles are counterclockwise, negative angles are clockwise. We don't advise you take the time to write a whole unit circle. If you need to, be quick. But I don't see anything wrong with drawing quadrant 1 if that helps you, or drawing the little quadrantal thing, because the multiple choice especially, we seem to have a little bit more time. I don't know what this next thing means, but I wanted to remind you of your tan tricks. So there they are again, your denominators of 6, 3, and 4. You want to know those, okay? The tan tricks, and then, the different quadrants of different signs. And this is something that I still see you guys getting confused on. Cosine always comes first, sine comes second. Cosine is x, sine is y. It's alphabetical order, just like x and y are, okay? And like I said, in the next couple days, I'm going to go over some other things I've thought of, some common mistakes I've witnessed you guys make throughout the year that you can add here. So just hold on to this pink sheet. I don't want to do everything in one day, okay? Hold on to that. We've talked about at length a lot of things. One of the things we've been talking about, especially the last few days, is how College Board has posted that a 3 is a 21. That is so attainable, you guys. That is so attainable. And I really think the FRQs we're learning, getting a little more comfortable with. We know some places we can get some points. But really, where it's at is that multiple choice, okay? And some of you are already there. Let's just make sure you're there on Monday. So I wanted to give you guys an opportunity to ask questions from the multiple choice if you have them. If you want these questions, feel free to grab one or use your answer sheet to ask me questions. But I want to take a little bit of time before I give you my little surprise and answer some questions. Let's clear some stuff up, okay? We don't have to do it the whole period, but we only have a few more days. Levi? Yeah? Okay, so I said I was going to start with a non-calculator, but let me just do this 84 for him real quick. You don't need to have the paper in front of you. Let me just write it, and I can explain it. Okay, we're given a natural log equation. We're also told when x is 3, y is 6. Find when x is 10, what is y? Okay, so I am going to plug the 3 and the 6 in to this and simplify it. So I'm going to start with natural log is P of t. Let's do this. So P of t would be like your y. So y is 6 when t is 3. So I have c squared times 3. Okay. So that would be 6 equals natural log of 3c squared. Okay. How you solve natural log equations is base to the power equals that. So this would be e to the 6 equals 3c squared. Are you with me so far, Levi? The base of a natural log is e. Okay. Anytime you have to solve a log or a natural log equation, you rewrite it in its other form, which is what I did. So all I did was plug in y that was given to me and x that was given to me, t, p of t, and I'm solving for c. I'm going to be able to get my c value here. So I'm going to divide by 3 and then find the square root. So c is going to be e to the 6th over 3, finding the square root. All of that is going to go in my calculator, okay? So, what is that? What is that? Let's see. I don't know what I'm doing here. I do, but I don't. C squared equals that. Oh, actually, wait. Let's go back a step. So I have e to the 6th equals 3c squared. I'm just going to divide by 3, and I get c squared equals e to the 6th over 3. I'm going to leave it as c squared because, look, I'm going to be able to just plug it right back in here. Okay, so I just use the given ordered pair, 3, 6, in this equation to find c squared. What we really want to know, though, is what is y when t, or x, is 10. So I'm going to do natural log of c squared is e to the 6th over 3 times 10. And then that just goes in your calculator. So natural log, hit your natural log button, e to the 6th. Oops. 6. Divided by, nope, not divided, oh gosh, pay attention, times 10. Why did I get the wrong answer? Natural, I need to type this in. E to the 6th divided by, oops, oh my gosh, divided by 3. Let's see if I can get it right this time. Yeah. Okay, so that would be, and there was a multiple choice answer that matched that, 7.20. So natural log, and above the natural log button, Levi, is the e to the x button. Now, that problem's got a lot of steps, right? This is on the calculator portion. This might be one that I'm like, oh, I remember this one. I'm going to pick my letter of the day and bubble it and then go back if I have time, because maybe I don't have enough time to spend on a problem that's this long, okay? All right, let's go back to the non-calculator section since that's what I said for you guys to pick up. Questions? Number what? Okay, so number 11, the polynomial function p is an odd function. If p is positive, this is one that, it's funny that you asked about this one. This is one I'm actually confused about, and I'm not sure why the answer is this. I don't know if there's a typo or something, but number 11, I have a star by it that I need to get more clarification on it. I'm hoping they don't have anything, because I thought I read that they weren't going to really go into even odd function stuff, because it wasn't like really emphasized during the school year. So let me hold off on number 11. I don't think it's going to be on there. But number 12, let R be a rational function. That's fun. Lots of factors in this. Which of the following descriptions about the graph of R of x is correct? Okay, so before I try and do anything with that, I'm going to go through all the different choices. What are we talking about here? Oh, asymptotes, vertical asymptotes, and holes. And if you remember, vertical asymptotes come from your denominator, holes come from your denominator. Two different things happen. If you cancel, you are a hole. If you're left in the denominator, you're a vertical asymptote, okay? So, and I think there's something weird about this one. Let me look. Okay, so when we cancel x plus 2 with an x plus 2, cancel one of those for one of those, cancel the x plus 5. Okay, So right away, you know that there's going to be a hole at -2 and at -5 because they're going to cancel. Those two cancel. He's talking. I'm listening. So I definitely have holes at -2 and -5. Here's where the weird one comes in. So we do cancel one here. See, we cancel one x minus 4 for one of these x minus 4s, but there's an x minus 4 left over that made a hole at x equals 4. Yeah. Okay, number 5. Let f be a function with this domain. So domain is the x values, range is the y values, hint, there's the letter. Okay, so that's function f. Function g is this, which is a big mess of numbers, but what it's saying, really quite simply if you really look at it, is g of x is created by taking f of x, whatever it may be, and doing this stuff to it, okay? What stuff? Well, we have to know what each of these numbers mean mathematically to a function. The 3 in front or right after the equal sign is a vertical stretch by factor of 3, right? It changes our y values, makes them bigger, okay? This 2 in the parentheses is a horizontal stretch, or let's just say dilation, by a factor of 1/2. It does something to the horizontal, to the x's. We know that that's left 4, also a horizontal movement, and this is down 1, which is a vertical movement. So the 3 and the -1 do stuff to the y values of a graph, of a function, and the 2 and the 4 do stuff to the x values, okay? So that's important to know. Now, let's go back. Which of the following gives the domain of this function? So we have to do anything that's being told to be, they're telling us to do to the x values, and there are the x values that we're going to do it to. We're going to take the f function here and do that to it. So you really are only going to focus in on this part, the 2x plus 4. That's the only part of g of x that's going to affect f of x's x values. So I'm simply going to drop this right in the middle, and that will change the x values according to what it said to. So we just solve from there. Divide by 2. And then the answers are in interval notation. So that's that answer. Daniel, talk to me. You sure? Okay. More multiple choice. Dylan? Sure. Okay, so function k is given by k of x equals this. We're between 0 and pi over 2. Which of the following is not an equivalent form of k of x? This is where you have to remember the sum and difference formulas for cosine. And if you remember, for cosine, here it is expanded. We're taking the alpha and the beta, in this case a and pi over 3, and spreading out. Remember, cosine is not social, so you do cosine with themselves. You always start with cosine A and then cosine of the other one. And with cosine, it's opposite sign in the middle. Sine, it's the same sign. And then you have sine of alpha times sine of pi over 3. Don't forget, we talked about this, so let me just remind you. This is alpha, this is beta, and it's always in that order. Alpha, beta, alpha, beta, alpha, beta. And then things are just plugged in. So we don't know what cosine alpha is, and that makes sense. All of your answers have just alpha in it. But we know cosine of pi over 3, that's the one closest to the y-axis. That means it's 1/2. So that's where the 1/2 comes from. And then sine of pi over 3 would be that. And then that's just simplified down to just put the 1/2 in front. Say it again. Yeah. So if you remember cosine with alpha, beta, let me do a sine. So remind you, whenever you're doing the sum or difference formulas with sine or cosine, they're both in each of them. Like you're going to have sine and cosine in this sum, you're going to have sine and cosine in this one. So remember we said cosine is not social. So cosine only hangs with cosine, and the sine is opposite in the middle, and it's sine, sorry I'm squeezing, sine of beta. Versus if it's sine, you always start with sine alpha, just like you started with cosine alpha. And then sine is social, likes to hang out with other people, like cosines, but I'm always putting alpha first and beta. Sine in the middle matches, and then we have cosine alpha, sine beta. So you might want to go back and look at your sum and difference formulas, and that's unit 3 towards the middle, I would say, or Google it, and maybe that's something you want to write down to study. Okay? You back? 6? Mm-hmm. Okay, great question to talk about, because using the answers to help us is always really valuable. In number 6, we're given this. And we're told to find the value of it. So solve, simplify, okay? And if you notice, all of our answers don't have the word log in them. That means there must be some way, without a calculator, because we're on the non-calculator portion, there should be some way that I can simplify these and get rid of the word log. And there is a way. Some things to remember. A lot of things you guys have, we've learned a lot this year. That if you have a log with any base, and that same number here in your argument place, it equals 1 or cancels out. So I can get rid of this log in its base if I have a 2 right here, okay? And there's a way to do that. I can rewrite 8 as 2 to the 3rd power. And then since we are in log land, we can use the properties of logs, which says that that 3 can come down in front. Log base 2 of 2 is 1 or just cancels out, so I'm left with just log here, okay? Did that make sense, Levi? Okay. Something else to remember is that when you do a number to a fraction exponent, you can rewrite it as a radical. Okay, like 4 to the 1/2 is also the square root of 4, which is 2. So same concept here. I know I can get rid of log base 9 if only I could make this 1/3 into a 9. I know it's got to be a 9 there, so I got to work some magic somehow of making this into a 1/3. So I know if I do the square root of 9, I get 3. So that would be 1/2, right? 9 to the 1/2 is 3. How do I put that 3 in the denominator? Make it a negative. Okay? So 9 to the negative 1/2 is the square root of 1/9, which is 1/3. So this negative 1/2 is going to go to the front, and then the log base 9 of 9 just cancels. So I'm just left with 3 plus negative 1/2. You need a common denominator. That would be a 2. I don't know why I wrote that plus there. You don't need it. So multiply that guy by 2, that guy by 2. 6 minus 1 is 5. Okay? So, would you remember that had I not gone over it? I don't know. But that's why we're talking about it. And what I want you to take away from that problem is, again, I have logs no calculator, and no logs in my answer. So there's got to be a way I get rid of them. You know what I mean? Maybe talking yourself through that, the problem and what has to happen, your brain comes up with the solution. Okay, so 19, the polynomial function h is shown above and is known to have complex zeros at x equals 2i, x equals 3 minus i. What is the least possible degree of h? So remember, degree is the biggest exponent of a polynomial, the biggest number. If it's in standard form, it's the first number, x to the third, x to the second, okay? So we want to know, does this guy have a degree 3, 4, 5, or 7, right? So there's two things we have to look at here. First, we can look at the graph, okay? We get our degree is related to our number of solutions, zeros, x-intercepts, whatever, okay? So we have actually 3 x-intercepts here, 2. There's 1 here, right? But we have a bounce here. So this bounce, or touch and turn, is 2 solutions. This cross is 1 solution. So we're already at 3, all right? But there's got to be a reason they gave us these 2. So did that part make sense, Atlas, just that part? Okay. And if you remember, we can have imaginary solutions. That just simply means before they were i's, they were negatives under a radical. And if you're a radical, you have 2 solutions. So if you remember, we talked about i's travel in pairs. So this equals 2, and this equals 2. Because if there's a 2i, there's also a negative 2i. And if there's a 3 minus I, there's also a 3 plus I. I's travel in pairs because they originate from a radical. So that's 1, 2, 3, 4, 5, 6, 7. This one would have 7 possible at the least. Oh, did I not? So that was probably, yeah, the answer is 7. Does that make sense? I's travel in pairs. They don't show up on the graph. They're imaginary. We don't see them. But anytime, like if you solve this equation, you'd say square root of this, square root of this. Anytime I take the square root of something, I have a plus and a minus. Square root of 4 is 2, and the negative makes it an I. So you're always going to have 2 solutions. Okay? We just don't see that step. We're just given, you have this solution. Well, if I have that solution, then I also have this solution. Okay? I want to give you guys my little surprise. I also